Hello, I'm Yael Balla, and I'm going to talk to you today about design systems. In my previous place of work, Kenshu, I drove the implementation of a new design system. And in my current place of work in Vision, I was in the other side, adapting a new design system to our product UI. So I'm here to share my experience with you. Well, I'm a Fed for a few years now, and during this time, I implemented several projects. And in every new project, almost every new project, I had to redo the same basic components over and over again. Why? Usually it wasn't because my code was wrong. A lot of times it was actually because of the design. There was a new designer or a designer with new ideas, and he wants the application to look a little different, to look new, and maybe the old design didn't match. And this was a very frustrating process for me because I wanted to focus on new feature, on scale, on performance. I didn't want to redo. I wanted to use what I already done and not redo it again. I think this is a common problem for organizations who don't have a clear design language, and this is the major problem that design systems come to solve, to make sure designer and developer are working on the right things and not reinventing the wheel all over again in every new project. So before we'll start, I want to show you my son. He's 7 years old, and he built this amazing ship from Lego with all the small pieces. It took him a month. But he came to this process with confidence. He knows how to build Lego. He has the instructions. He has the building blocks. And this is the result. And when he was building it, I was thinking, wow, I wish you could build software like Lego. And this is not a unique thought. Design systems are the big promise of the UX world. If you have a design system, you can design new screens and new user flow faster and better. No more conflicts. The designs should adhere to the same rules defined in the design system. But what does it mean for the developer? Is the developer also get benefits from that? Well, the answer is yes. Now all the designs should match the components and definition in the design system. And in addition, the design system also include code components that you can reuse in your new applications and new projects. So what is a design system? This is not, I'm sure you already heard about it, so let's just do a short recap of what a design system is. Design system is the complete set of design standard, documentation, and principles along with the toolkit. It means the design system is not just one deliverable, it's a set of deliverables. It's also provide resources for the designer and also for the developer. And this is the big change. Design systems, they are composed of a few layers. The basic layer is the font, the typography, the assets, icons, images, and above that you build your components, your templates. And the third layer is the abstract one, is the one that usually most difficult to achieve. It's the brand values, the shared goals, the mindset, shared beliefs. We'll see an example. So here are a few examples for a design system. All the big companies today have design system or building one, and in the spirit of open source and giving back to the community, they are also sharing the design systems with the world. And good PRs, of course, it's also important. So IBM have Carbon, Salesforce Lightning, Google Material Design, Spotify Polaris, and this is very trendy. So there is also sites that show you the different design systems that are publicly open that you can later on surf and explore. So this is Lightning. This is the design system for Salesforce. Every design system is different from what from the resource they give to the developer. In this case, this Lightning give you a cross browser CSS, but let's look first on what I said before, the abstract layer, the common rules. So here you can see the design principles that are important for Salesforce, and they judge the designs based on that, on clarity, consistency, beauty. It's not necessarily a thing that you can reflect back on code, but it's there and it's important. But what do you get as a developer? So as I said, you get a list of components, and you get for each component the markup that you should create in order to write JavaScript for this component. And you can import the CSS file into your projects. Carbon is another design system for IBM, and of course it has its own UI, but what is special in this design system, they actually invested in providing implementation for all the famous and popular UI framework like Angular, Vue, React for each component. So if you go to their documentation, you will see how to create it in every framework, and there's also a matching package in NPM, and you can import it in your code. So it's a lot of work. Is it worth it? Definitely. It's not just for big companies. Also medium companies and smaller companies, they want to reuse what they've done, both in the design part and both in the code part. And we all were in a place when we got a new design and we wanted to use a button, but there was 5 different buttons in the application. We didn't know which one to use. So the design system is a place where is it the source of truth, where it's a place where you can look at and know what you should use. So what are we as a developer can do for enabling the process of starting a new design system? So first, it's a conceptual change. It's not just us writing good code that is possible to reuse. It's work that needs to be done across the organization. Dev, design, and product should work together and take a decision. They are sign some contract that this is the design language we want to use in the following time. I don't know, and it usually sometimes it can take years, sometimes more, until you update your design, but you're taking the decision to work together, and after you have this buy-in from organization and you took the decision, then the next thing is to understand the rules behind the design. And this is, again, something that need to be done with the designer. You need to for example, to understand how do you mark importance. Maybe important item hover, maybe they get the brand color, maybe they have some kind of animation. What is the grid system that your application is using? Sometimes it's abstract, and but sometimes you will get interesting insights that you can take into code. For example, maybe you should implement a 3 columns layout because most of the screen are based on this layout. So now you have the buy-in and you have cooperation and you know what you want to do. So the next thing is to define the smallest layer, what it is called design tokens, and this is what you can translate into CSS variables usually. And the important thing and the change here in design system is that it's not just about defining the values as variables, is that you need to provide them with meaning. For example, it's not that you have a specific green that you repeat in your application, you have this green is used for success, and this red is used for danger. And when you get a design, you can take a look on the design and see if the colors match what the original intent. And also, when you will get a design, the name of the variables inside the design should not be the color number. It shouldn't be F36. It should be color pink, or even better, it should be color brand. And these files, for example, here it's SAS, then this file is no longer just the developer responsibility. It's in code, but now it is part of the responsibility of the designer. He knows this variable, he knows he should use this, and he will not just add a new color or in a new design add new type of gray or new type of green, because this is not part of your contract. The same can be done also for sizes, for spaces. You can declare a scale system and use it from now on. You no longer need to talk about 12 pixels or 1 pixel. Okay. And you now talk in a matter you talk with this boom was learning. So you're now talking with. You're talking with T-shirt sizes, small, medium, large, and it's now easier to create a pixel or perfect design, and it reduces your mental overhead because you just use the predefined sizes. And this also allows you to create utilities classes that later on can help you write little to no CSS at all. So what's the best way to define these variables? It doesn't really matter. You can do it as in CSS in JS, you can do it in SAS. You can even define components that actually that can hide the CSS implementation inside. They can wrap your component with padding. They can style your text, and every technique you will choose is legit, as long as you keep it meaningful. As I said, no more one-offs. You have a contract with the designer, and now you know you can really reuse what you already defined. So you have the smallest building blocks. You have the buy-in from organization, you have the agreement with the designer. So now you can start defining your visual component. But as we said before that, not of us are lucky to start a new project just from scratch. Most of us actually have already have a product, and we need to start with that. So the first thing is just create a folder in your repo, call it design system or components or basic lib, whatever, and start moving your code into it. So let's look on example. In this example, you have a list. This list, like many other lists in many different projects, combine both business logic and visual parts. So let's take a look about what's in it. So we have a redirect to error page in the component did catch of. This is a React example, but I guess it's applicable for other frameworks too. So we have an error boundary. We don't know, it's not necessarily have to be in every component. We'll later take it out. We have metrics reporting in the render method. Again, this is not part of the visual layer. We would like to take this out as well. There is a decision that should be made if to show the delete option to the user or not, according to its authorization. This one also shouldn't be part of the design library. The application should control it from outside. And now we get to what's actually need to be done. You need to traverse on the list of items, and for each item to render the matching component. And later on, according to the decision, to decide if to show the button or not. So let's start. Take this list as an example. So first, error boundary. Many things that we repeat all over in different components can actually move into a different one that wraps it and take this responsibility. In this case, error boundary is just a simple example. For metrics reporting, we can use a higher order component. A higher order component is just a function that receives a component and return a new component with extra functionality. So for the metrics, we can use a higher order component that in the render method report the metrics, but it can be in any lifecycle method. It doesn't have to be just that. Okay. Very exciting. Okay. And another, let's hope it's just fireworks. So another technique we can use is to separate between the visual part and the business part, and to give control from outside is render prop. This allows you to pass the responsibility from parent component to a child component using a prop whose value is a function. So let's look on the list we would like to have. So we will have a list that in the render method traverses on the list of items, and the rendering is done via item renderer, and it's not included in the list itself. But the item code is still part of the library. We should separate between the item and the list, and the parent component should decide which item to render and if to render. So we took a few of the functionality outside, and now we have the application list. So this application list, you can see the error boundary that wraps the list. It provides it with the item renderer and wrap it with higher order component for the metrics reporting. How to create the item renderer. So here we have an item renderer creator. It's a function that returns a function that rendering the items based on the action and the user authorization. And this is our result. In the application code, we have the application list, all the other code we extracted out, the error boundary and the metrics higher order component. And in the library, which is the design system component, we have the image item, the item label, and list that contains now only the visual parts. Another question is when you separate between the visual layer and you move component into a library is the customization. From one hand, we want the user to be able to do what they want, because we all were in a place when we had a component which is very similar to what we want to do, but we can't use it because it's not. There is one thing that we need to add and it's not supporting it, and then we need to rewrite it from scratch. But on the other hand, we are implementing a design system. We want it to look and behave as we want, as the design decide, and not allow any customization. Well, since we write code, we must give the user option to customize our component, and usually comes into three parts. One is the styles. Yes, the design system define all the styles for you, but you still need to allow them to pass a class name into your component, because sometimes they just want to do a key into integration design, sometimes the integration test, sometimes they want to control the layout to put it inside Flex or Grid or whatever, and they still need this endpoint. The second thing they would like to probably to update is the props of your inner children. You don't always want to wrap every inner prop and to expose it as your own. For example, input. Maybe if you want to control the type, we saw there are a lot of types for input. So if we want to pass it inside, so maybe you should just propagate your properties into the child component. And the third option is to, if you can skip the if you can pass the control on render to your parent component, then allow this. You can always have a default render, but if you can also get the render from outside, use it. Oh, sorry, I had colors. So not every shared component should be part of the design library. For example, if you have a login screen, or maybe you have a document configuration, it's maybe shared across the applications of the organization, but it's not part of the design system. It's not one of the basic components. This kind of UI should maybe get its own package, or maybe it should be copy-pasted, but it should still be composed of the basic component of the design system. So I mentioned the shared library. When the project starts to grow and you want it to arrive to different teams inside your company, usually it means that you want to export it, to manage it as a separate package. Of course, we manage packages through NPM, and in order, every build tool support it, and of course Webpack, if you want to declare your code as a library, you just need to add the library property inside the output and set the target. For React, it's usually common.js, because you want to import or require this. The second thing is in the package JSON to set the main, because after uploading the library to registry, this signals which file will be served as the entry point. Also, in web, if you provide the library, you usually don't want to be bundled with all your dependencies. So for that, there is a library, there is a package, Webpack Node Externals, that creates the externals list for you out of your Node modules directory. This is important also if you're using React. You don't want to be bundled with React and React DOM. So this saves the time to actually define it manually. One of the issues when creating or separating the code into a different package is that you need to rebuild it in order to, and import it into Node modules in order to get the latest version of the code. And NPM have a command for it, npm link. It's create a symbolic link into the original source code. So when you change the source code, your applications receive this update and can recompile. When you have a package, you start to think about version management. Even if it's internal, you do want to signal your users if it's safe to just upgrade or that you did some breaking change. So semantic release can help in this thing for you, and you can also integrate it into your CI. With this package, when you write a commit message, it also controls the matching version. For example, you write nothing or just write fix, then it's a patch release. And if you write major in the commit message, it will release it as major release. So great, we have the buy-in for organization, we have cooperation with designer, we have our building blocks, we have our variables, we have components, we even have a shared component library. Everyone can use it. Great, we can now rest. Well, the answer is no. Why not? Because if no one knows about it, it doesn't exist. And the whole thing about design system is to be the source of truth, shared across the organization, where people from different teams can see what's in it and see the current status and how components behave. And it's not enough to look just on the sketch file. You want to see the actual component and what the user is really getting. So for that, we're front-end developers. We can just write a static website. We saw Carbon and Lightning, and we saw their website, and their website is really frightening. It took a lot of work, and if you're a big company, the design system already, it's a product of its own. There is a team maybe that updates it, but if you just start with it, any simple static website that includes the design principle, what resources provided, and real-life component can help with this task. If you don't want to write it by yourself, there is a tool called Storybook, which is a UI component development environment that allows you to define stories for your component, to declare the different states and different properties. And then you can generate static websites with live component that will allow even designers to play with the properties and see the different options. Getting started is simple. There is a CLI you can use. It detects your project configuration and create config files for you, and also provide you with a basic index file. It also adds to the scripts in the package JSON a build storybook command that you can use in order to generate a static website. This is what you get if you're just the default, not very interesting. So now you need to add the stories. You need to add your components list. You need to add their states. You need to add their you need to add code. Each story is so what is a story? Each story represents one state, but it's just 6, so you can write whatever you want. You can render one component, 2 of them next to the other, build a form. It's completely flexible. So let's add a story. You need to everything you add here will be shown in the left navigation. So here we add a story for a button, which we give it a name. It's a default theme, and we render the button. And later on, this is what will be shown in the UI. So default is nice. We saw this basic thing, but it's very thin. And to add functionality, we need to enable some add-ons. So I recommend usually 3 add-ons that provide a lot of capabilities. Info, it generates the README for each component. Knobs, it allows the user to edit in live mode. And option, control the storybook default UI settings. There is a documentation on Storybook site, so I will not show how to incorporate that. Just take a look. Here we can see the React component for the Carbon design system that I mentioned, that they have support for each framework. So they use Storybook for the component showcase. We can see here the list of components. Here we can see the accordion, how it looks like. And we have also, for example, the breadcrumbs. We can see the story for the breadcrumbs. We can see which properties it's allowed to change. There is also the information on that. So this is something that it's easy to add, and you don't need to write your own code in order to create this site. And it also comes with a lot of extra benefits, like like testing and live component updating or visual test and so on. And this is also important because because in design system, the code is the source of truth. When we build a project, we don't use what's defined in the sketch file. We use what's defined in our code. So we also want designers to reuse this in their designs. It's not just enough to see it on the design system site. They also want to sometimes include it in their sketch file. So there are tools for doing that. For example, Airbnb, they released the React SketchUp that converts your React component into sketch symbols. And there is also, after that, because it's only limited to React, after that it was also released HTML SketchUp, which can actually convert any UI into sketch symbol, and later designer can use what's implemented and not what's defined. Okay, they can use the source of truth. Another thing that the design system can bring you is to have visual tests as part of your CI/CD. Lego never changes, but our components do change. And when we change things, we think it's great, but usually the designer see them and said, oh no, it is 1 pixel more. And the designers would also like to see what's in there before releasing to production. So you can also add a step that before it's merged or released, it's also send some notification to the designer to take a look, approve, and continue. So I mentioned a lot of tools and a lot of processes, but who is managing this? It's not DevOps, and it's not production, and it's not designers, as they're responsible for the creative part, and it's also not really the developer task. This brings a new head to the organization, design ops, which it sounds similar to DevOps, and it's a responsibility on the tools and the processes for managing and scaling the design workflow. These are things like tools for design, collaboration, developer hands-off, asset management, training and onboarding. It's research and user testing. I can give an example. In my last place of work, we wanted to record real user sessions, and there was it came from the UX team, but it was a lot. It took us a lot of time to get to this task because it wasn't clear who is responsible for it, and eventually one of the developers actually took the initiative and do the POC, but as more tools comes on, and more needs arise, we need to have someone who is responsible for that, and this is the design ops mission. So this concludes my talk about design system. And I hope you enjoyed it. There is a lot of resources. I will also share a slide for extra reading and useful links. I hope you like the concept of design system like me, and you will take it to your organization. But if there is one thing I want you to take is break the silos, work together. Sit with your fellow designer, ask him about his design system, design principles, ask him what tools he is using, check if he's using a known design system, maybe as a baseline. It can save you a lot of time. Think together how is best to define the design tokens in code, what is the gap between the design and the application today, and work together to limit this gap. I think that if design and dev will work together, building pixel-perfect applications will be like playing with Lego. So this is we will share the slides later, so you will have this and everything for you. So thank you for listening. If you have any questions, I'm here in the conference, and you can also reach out. Don't hesitate to reach out via mail or LinkedIn. Thanks.